In this video, we're going to look at systems of equations that look something like this, where we have our x and y on the left side of the equation. Now, we could rewrite these equations as y equals mx plus b, and then use substitution. But when we have the x and y on the left side of the equation like this, there's a new technique we can learn to solve this. So let's start off by representing each of these two equations with a picture. Let's bring in a picture that we've seen many times now with our person equals person. We have the same thing on both sides. And we'll use this to represent our first equation. And we'll find a different object to represent our second equation. So let's use Skittles. Skittles equals Skittles. So this picture right here will represent our two equations. And in both equations, the left side equals the right side. Or, in other words, we have something equal to something else. What we're going to do now is combine these equations. So we're going to combine our left sides and combine our right sides. So, looking back at our picture, we're going to take the items on the left side and we're going to add them up. And we're going to take the items on the right side and add those up. And what we notice is that these two sums are equal to each other. So we started with our original equations, and then we represented them with a picture. And we added the pieces on the left side and the pieces on the right side, and we saw that they were equal to each other. So how does knowing this help us solve our original system? Let's bring this system of equations down and apply what we've learned. So we know now that if we combine the pieces on our left side and combine the pieces on our right side, those two will be equal to each other. So let's try that out. On the left side, we have 3x plus 4x, which leaves us with 7x. And we have minus y plus y. That just leaves us with 0. So our y has disappeared. Now let's look at our right side. We have 13 plus 1 gives us 14. So adding up the pieces on the left side and adding up the pieces on the right side left us with an equation with just x in it. Our y disappeared. So now it's pretty easy to solve for x. All we do is divide both sides by 7, and we're left with x equals 2. So again, why do we combine our left sides and our right sides? Well, we do this to get an equation with just one variable. Once we find the value of one of our variables, we can use substitution. So we'll substitute our x equals 2 into one of our equations. If we use our first equation, we'll have 3 times 2 minus y equals 13. Simplifying this, we have 3 times 2 equals 6 minus y equals 13. We can subtract 6 from both sides, leading to negative y equals 7. Divide both sides by negative 1, and we have y equals negative 7. So the solution to our system of equations is x equals 2 and y equals negative 7. So you might be wondering, What's the point of combining if we're just going to substitute afterwards? Couldn't we just use the technique from the last video? Couldn't we write each equation as y equals mx plus b and use substitution? Well, yes, we could do that. However, learning how to combine equations lets you see the system of equations in a different perspective, which can improve your understanding of equations. Also, combining equations is very useful in other math and science areas. So if you find yourself studying a STEM subject in college, you're going to run into this topic again, and you'll use combining equations to solve different problems. And another reason to practice combining equations is that solving these is kind of like solving a brain teaser. As we'll see in the next few examples, the problems aren't always as straightforward as this one here, but you'll get some clues, and from those clues you have to figure out how can you solve the problem, and doing that sharpens your mind. So let's get into an example. Find where the two lines intersect. So we have 2x minus y equals 7, and 3x plus 5y equals negative 9. So we want to find where the two lines intersect. In other words, we want to find the solution to this system of equations, which means we want to find our orange x and purple y. So if we try adding up the pieces on the left side and the pieces on the right side, like we did in the previous problem, we're going to run into a bit of an issue. We'll have 2x plus 3x, which gives us 5x, and we have minus y plus 5y, which gives us plus 4y. And on the right side, we have 7 minus 9, which gives us negative 2. So we added up the pieces on the left side and the pieces on the right side, and this is what we have. However, this is not what we want. Remember, our goal of combining is to get an equation with just one variable. Well, adding up the left side and the right side left us with two variables. So we need to try something a little bit different. Let's look at the problem again and try a different approach. So we want to combine these equations to get rid of either the x's or the y's. So is there anything we can do to these equations to make that possible? Well, if you look at those y's, it would be really nice if this equation said minus 5y, because adding up the left side, we could just get rid of the y's. So using that thinking, watch what I'll do. I'm going to multiply each side of the first equation by 5. Remember, with an equation, you have to do the same thing to both sides. So let's see what this leaves us with. To multiply the 5 on the left side, we use the distributive property. So we have 5 times 2x, which gives us 10x, minus 5 times y, which gives us 5y. And on the right side, we have 7 times 5, which gives us 35. And for the second equation, we didn't do anything there, so we can just bring it across. 3x plus 5y equals negative 9. So now, if we add up the pieces on the left side and add up the pieces on the right side, we'll get 10 plus 3x gives us 13x, minus 5y plus 5y leaves us with 0. The y's disappear. And on the right side, we have 35 minus 9, which gives us 26. And the rest of the problem is pretty straightforward from here. We have 13x equals 26, so we divide each side by 13. Remember, doing the same thing to both sides, and that leaves us with x equals 2. We can bring down one of our equations and substitute our x equals 2 in there. So we have 3 times 2 plus 5y equals negative 9. That leads to 3 times 2 is 6, plus 5y equals negative 9. We can subtract 6 from each side, leading to 5y on the left side equals negative 9 minus 6. is negative 15. Now we can divide each side by 5, leaving us with y equals negative 15 over 5, which is negative 3. So we know our orange x and we know our purple y. So we can say the two lines in our system of equations intersect at x equals 2 and y equals negative 3. That is where the two lines intersect, and in other words, that is the solution to our system of equations. We solved this problem by combining our equations so that we could eliminate the y. Let's try solving this problem again, but this time we're going to get rid of the x instead. So this is the same problem as before, but this time when we combine the equations, we're going to try to get rid of our x. So how can we do that? Well, when we were trying to get rid of our y, we multiplied the top equation by 5 so that we could have a negative 5y here. And so having negative 5y plus 5y got rid of the y's. So in a similar way, we want to multiply our 2x and our 3x by something to get to the same number. So what that means is we want to find the least common multiple. So let's list out the multiples of 2. 2 times 1 is 2. 2 times 2 is 4. Then we have 6, 8, 10, and so on. Listing out the multiples of 3, we have 3, 6, 9, 12, and so on. As you can see, 2 and 3 have a common multiple of 6. So let's see how that helps us. So I'm going to multiply the top equation by 3 on both sides, and our bottom equation by negative 2. That leads to 6x minus 3y equals 21. And on the bottom we have negative 6x minus 10y equals 18. Now when we add up the pieces on the left side and the pieces on the right side, we'll see that our x's cancel. So the point of finding the least common multiple is that now we know that we can multiply 2 and 3 by some number to get to 6. And once we do that, we can combine the equations and cancel out those x's. And from there, we would solve the problem as usual. We have negative 3y minus 10y. That is negative 13y. And on the right side, we have 21 plus 18 gives us 39. Dividing both sides by negative 13 leaves us with y equals negative 3. And we can take our y and substitute it in one of our equations to find our x equals 2. So it's your choice when combining these equations whether to get rid of the x's or get rid of the y's. Unless you're told which one to get rid of, pick the one that's easiest to get rid of. In this example, getting rid of the y was easier because we just had to multiply the top equation by something. When we tried to get rid of the x's, we had to multiply the top and bottom equations by something. So it just took a little extra work. Let's try another example. We have 4x minus 2y equals negative 3, and negative 6x plus y equals 14. Again, we're going to solve this equation by combining, and it looks like getting rid of the y would be easiest. We just need to multiply our bottom equation by 2. That leads to 4x minus 2y equals negative 3. Nothing changes on top. And on the bottom, we have negative 12x plus 2y equals 28. If we add up the pieces on the left side and the pieces on the right side, we can cancel our y's. So from here, the problem's really straightforward. Solve for x and substitute it back into one of our equations to get y. Now let's say we wanted to solve this problem by getting rid of the x's. How would we do that? So I brought down our original system of equations, and this time we're going to try to get rid of the x's. And it looks like we'll have to multiply both equations by something to get to a common number. So what's the least common multiple of 4 and 6? That would be 12. 4 times 3 equals 12, and 6 times 2 equals 12. So let's try to get to 12. We can do that by multiplying the top by 3, and we multiply the bottom by 2. That leads to 12x minus 6y equals negative 9. And on the bottom, we have negative 12x plus 2y equals 28. So when we add up the pieces on the left side and the pieces on the right side, we'll see that our x's cancel. Let's try solving this problem one more way. So here's our original problem. And when we tried to get rid of the x's, we found the least common multiple. And the thing is, you don't have to find the least common multiple, you just have to find a common multiple. And a quick way to find a common multiple of two numbers is just to multiply them together. So in this case, 4 times 6 and 6 times 4 gets us to the same number. So we can multiply our top equation by 6 and our bottom equation by 4. And that leads to a common multiple for our x's. So on top we have 24x minus 12y equals negative 18. And on the bottom we have negative 24x plus 4y equals 56. And adding up our left side and our right side, we see that our x's cancel. So multiplying two numbers together gets you to a common multiple. However, you end up working with bigger numbers. If you find the least common multiple, like we did in our second approach, you end up working with smaller numbers. And so adding up the left side and adding up the right side can be a little bit easier with smaller numbers. So the quicker approach would be to find the least common multiple. And usually, if you know your times tables, you can figure it out pretty quickly. Between 4 and 6, the least common multiple would be 12, and you can go from there.